Okay. So, oh, you know what? Let's go back just a sec to here, to D. Remember what I said we'd talk about this one this time, didn't I? So if we want to figure out whether or not that's a function, we got to solve for y equals, don't we? So how would I solve that for y equals? Okay, we're going to add 2x to both sides. And we have y squared equals 2x plus 5. And now what? We already squared both sides. We got to get rid of the square. Square root. Yeah. If you square root both sides, what goes in front of the square root symbol if we're solving? Plus or minus. So we have y equals plus or minus the square root of 2x plus 5. Guys, this will tell me whether or not it's a function. If I put one x value in, this is an x in, right? But what is this going to mean? How many y's am I going to have out? 2. Ooh. So for one x in, I get 2 x's out. Or for one x in, I get 2 y's out, don't I? So is that x unique? No, it's not, is it? So anytime you have a y squared in an equation like that, is it a function? No, it's not a function. What it is a sideways parabola. It would be, this guy would be a sideways parabola that would be like this. Okay? But this y squared term right here automatically will tell you, no, it's not a function. It would not pass the vertical line test, would it? All right. So, function notation. This is review from Algebra 1. Is everybody pretty comfortable with function notation? You remember how to plug something in? What f of x means? It's the function f that has the variable x in it. That is the independent variable, right? Okay. If we take g of 6, what is it telling me to do? Plug 6 into the function what? G. Plug it in for x in the function g, right? This is an easy way in math to label different types of functions. We can label them alphabetically, f, g, h, I, j, whatever, and then we know which one to use. Rather than doing y sub 1, y sub 2, it's a pain in the butt. All right, so g of 6, we're going to simply take what? 6 squared plus 8 times 6 minus 24, and we can find a function value, can't we? So what do we get? 60. Okay. G of negative 4x. Y'all always freak out when they put a variable in to be, this is 36 plus 48 minus 24. This is 12 plus 48 is 60. That's right. All right. G of negative 4x. What are you going to do?
Insert the 4, negative 4x into all the x.
Yeah. Everywhere you have an x, you could put in negative 4x instead. Now it's squared right here, so what are you going to have to make sure you put in? Put it in parentheses. Negative 4x squared plus 8 times negative 4x minus 24. Most of y'all, if you're going to miss this problem, you will miss it in the very first term. You're going to plug in negative 4 squared in your calculator, and you're going to get negative 16 out. What's wrong with that? And you won't even bat an eye at it because you're not paying attention. You're just plugging numbers.
It's in parentheses, and the parentheses change.
You put it in parentheses. It's a negative squared, which is a negative times a negative, which is a, thank you. So this would be what? Minus 32x minus what? 24? And I had somebody in another class say, is that all? You tell me. Can you do anything to that? No. They're not like terms, are they? You can't add an x squared and an x. Or a 24. All right, last one. 5c plus 4. This really throws people for a loop. You're going to plug in, aren't you? So you're going to have 5c plus 4 squared plus 8 times. Now, I use a trick for this one. I use what we call square, square, double. Did I teach you that already? Oh, guys, you got to know square, square, double. All right, look, it's an easy way to square a binomial like that. Think about it. 5c plus 4. I'm going to do this for you one time because we're in advanced precal and should know how to multiply these together. If you don't, rethink things. Well, you're going to, no. FOIL is what we're doing, but square, square, double is actually a shortcut, so you can do it visually. Yes. Look, what do? You multiply the first term. Isn't it the same as squaring 5c? So we are going to square the first term. What is 5c squared? 25c squared. So square 25c squared. Then we're going to square the last term because if you were foiling this, you would do the last term times the last term. That's like squaring the last term, isn't it? Get the square now? 4 squared is what? And then the double. Where does the double come in? Outer, inner. I want you to look at that. What is that? Outer and inner are both what? 5c times 4. So it's like you took the first and last term and then doubled it. Get it? So what is 5c times 4? 20c, and then double that, you get what? Oh. Square, square, double, guys. Or you could do square, double, square if you like everything in order. And then we can distribute this, can't we? So what is that? And then we just straighten things up. 25c squared. We got 40c and 40c is. And then we have 16 plus 32 is 48 minus 24 is. And we got an answer. Square, square, double. Guys, you can really do it fast. Just to show you, if I were to take 2x minus 5 and square it, watch square, square, double. Square this. Negative 10x doubled is 20x. Square this. I didn't have to foil it, did I? You don't have to write it out. It's just easy to do if you practice it. Square, double, square. Okay? Simple, simple. All right. Now, I will teach you stuff, little tricks and tips to make it math faster for you as I can. Implied domains and excluded values. Guys, implied domains means that for every function that we see, we automatically assume that the function is all real numbers, unless it either tells us through an inequality or the function itself implies that there's something we can't do. So, when you're given a function with an unspecified domain, the implied domain is the set of all real numbers. In other words, this. In general, you exclude values for a couple of different reasons. 2 major ones. The 2 major math no-nos that you know so far is we can never divide by what? Okay. So you must exclude values for the domain that would result in dividing by 0. In other words, we have a variable in the denominator. Okay? The other big no-no, math no-no that you know, is you cannot take the square root of what? Really?
2.
You can take the square root of 0. You can take the square root of 2. It's 1.14 something. What can you not take the square root of, guys? Say it louder and prouder. Negatives. Do you take the square root of a negative number? No. So anything that would result in taking the square root of a negative number. Okay? Now I'm going to show you some examples of what that would look like. There are 3 possibilities you will see from those 2 things. Let's look at A. An example of what A would look like. F of x is equal to 1 over x minus 3. What value would result in us ending up dividing by 0? If x was what? 3. How'd you decide that? 3 minus 3 is 0, right? Okay, so the way we figure this out is we take whatever's in the denominator and we say, what would make this equal 0? Can we solve that for x? X would be what? 3. So this ends up being the domain. This would say the domain would be equal to x such that x cannot be what number? Cannot be 3, where x is an element of the reals. That is the domain statement for that. That is set builder notation. Now, if we needed to do this in interval notation, how could we do it? What would the intervals be? If you're not sure, make it a number line. If we had a number line right here, 3 would have an open circle at it, and what else? What would be shaded? Guys, the only element of the real numbers that you can't have, you just told me, is x can't be 3. The shaded part represents what you can have. The open circle represents what you can't have. So what would be shaded? Everything else. So you would have an open circle here and shaded this way and this way. Why am I telling you to do that? Because this will help you figure out what the intervals are. How many intervals am I going to have? 1 here and 1 there, aren't I? What is that first interval going to be? Good. From negative infinity to 3. Is 3 included or excluded? Union of that with what? 3, 2. Okay. So if you don't know what something looks like to do interval notation, take the set builder notation, turn it into a number line, shade it, and then the shading will tell you where your intervals are. Okay? Easy. So that is dividing by 0. What will we do if we have a square root of a negative number? Let's do 2x. 2x plus 3. Not quite so easy, is it? I'm going to ask you, what can you not have? Okay, negative 4 wouldn't work, but anything else? Negative 2. Okay, so there's going to be a bunch of numbers here, isn't there? As a matter of fact, there's going to be a whole bunch of numbers, but we need to figure out what those are. Majority of negative numbers, but you can't really write that as an answer. So how do we figure out where all those negative numbers start? Well, what do we know? This can't be negative, can it? So we take whatever's underneath the square root symbol and we turn it into an inequality. For something to not be negative, it must be what? Or 0. Doesn't that right there mean greater than or equal to 0? Doesn't that mean positive number? So can I solve that inequality? Boom, yes I can. So how do I solve it? So 2x is greater than or equal to -3. So x is greater than or equal to what? -3/2. Okay. That right there tells me where all those negative numbers start. It is the majority of them. It's everything from -1.5 back, isn't it? Okay? So, how do we write that in set builder notation? Domain is what? X such that x is greater than or equal to -3/2, where what? X is an element of the real numbers. Remember, if it's an inequality already, this one should be an easy inequality to do in interval notation too, shouldn't it? If it's greater than or equal to -3/2, what is that interval going to be? Okay. So bracket, -3/2, why bracket? And all the way to infinity. Either one of these would be a correct answer. Okay? All right. Let's look at some other examples and let you guys try this a little bit. How do I know which one to use where? That's always the question. Miss Duffy, how do I know which one to use? Well, let me tell you. It says state the domain of the function. Really what it's asking you is find all the restrictions. So the first thing you're going to look at is you're going to ask yourself, do I have an x in the denominator? Yes. That means it can't be equal to 0. But then you're also going to look at, do I have a square root? No. So if all I have is an x in the denominator, you're going to do exactly what we did before. You're going to ignore the numerator. You're just going to take what's in the denominator and do what? What did we do in the example problem? Set it equal to what? That's the thing, is nobody ever remembers, when do I set it equal to 0 and when do I say it's greater than or equal to 0? We only do the inequality when the square root is present. No square root, no inequality. So, can you solve this? And if you tell me to divide by x, I'm going to get irritated. No, I won't. But no, do not divide by x. You have a right impulse when you say divide by x, but instead of dividing, we do what? Starts with an F. Yes, we factor it out, don't we? If your impulse is divide something out, factor it out instead. So what does this factor into?
X minus 7.
Okay, so now we've got it factored, so what can we do with the factors to solve?
7 equals 0.
Yes, thank you. So we have x equals 0 and... Do I need to do anything to x equals 0? No. We already know 0 is excluded now, don't we? Well, what else is going to be excluded? X equals what here? So we have 2 excluded values, don't we? So how do we write that in set builder notation? Easy. X such that x cannot be what? Or where x is an element of what? What is always going to go over here for these type of problems? Real numbers. Now, here's the hard question. What's the interval notation for this? This is where you do the number line. If I were to do a number line sketch here, what 2 numbers would I put open circles on? 0, and it's 7, and what would I shade? Everything else. How many intervals am I gonna have?
3.
Thank you. See how easy that is? If you do that interval, if you do the little number line, you get it, and it's easy. So you got 1 here, 1 here, and 1 here, don't we? So what is the first interval gonna be? To what? And then what do I put between each one of these intervals? U. And then from 0 to where?
0 to 7.
And why am I using parentheses for all of these? Because they're not included, are they? And then from where? Okay, this is why they pay me the big bucks. Not really, but nobody teaching gets big bucks. But now, do we do B the same way we do A? What's the big difference between B and A? Square root. So instead of doing this equals 0, what do we have to do with this stuff under the square root? Inequality. So we say t minus 5 and we do what? Inequality, and now you tell me set it equal. Which one is it? Look at your example. Has to be positive. For it to be positive, what is that inequality? I'm hearing, I saw you mouth it, and I think I heard you say it. What is it? Yes, greater than or equal to 0. Because of the square root. For the square root, yes. Because why? You can only take the square root of a positive number, and greater than or equal to 0 implies it's positive. So yes. So now we solve it. So t is what? Okay. So give me the domain in set builder, and then give me the domain in interval. Oops. Aha. I made the same mistake about a bunch of you did. Did everybody go X?
Yeah.
What's the variable here? Hello, T such that T is what? Where T is an element of the reals. Be very careful with your variables. Use the correct variable, okay? Now, what is the interval? Okay. All right. Good. Now, I want you to look at something. Look at C. C is like the ultimate because guess what we have? Both. Which means that we have this guy right here, right? Which means we have to use an inequality. But because it's in the denominator, instead of using greater than or equal to 0, what do we write? Nope. Oh, say it.
Just greater than.
Why just greater than?
Because it can't be equal to.
It can't.
It's in the denominator.
Yeah, it's in the denominator. You've got a variable in the denominator, which means it can't be 0, right? And then you've got it under the square root, which means it needs to be an inequality. So if you take the inequality, x squared minus 9, and you set it greater than or equal to 0 and say it can't be equal to, doesn't that pretty much just get rid of that part of it? Yes? Okay. Now, y'all learned how to do these last year. I know you did. How to solve an inequality like this. You probably just don't remember, so I'm going to refresh you. Remember I said I'm going to find all the algebra problems that you had and stuff you forgot, and we'll remind you. How do I solve x squared minus 9? What do I have to do with that? If it's a quadratic, I have to do what? Starts with an F. How do I factor x squared minus 9? You don't need to complete the square. This is the difference of two squares, guys. You should just know these. Thank you. X plus 3, x minus 3, greater than 0. Now, most of you could probably get it to this point. But what you forget is when you have factors like this, how do you figure it out? This is where the number line comes into play. And some of you are going to go, oh, if I were to solve this guy, what do I have? X plus 3 equals 0 is what? X is what? So we're going to put negative 3 on the number line here. And from this guy, what are we going to get? 3. You should remember this. When you have an inequality like this, it's either going to be the two outside are going to be the solution, or it's going to be what's between. It can't be both. So you have to pick numbers. Remember where you had to pick numbers in each place and tell whether or not it worked? I'm going to tell you right now, you don't have to pick numbers. I always pick a number in the middle. Because if the middle doesn't work, if the middle does work, guess where it's at? In the middle. If the middle doesn't work, then guess where it's at? On the outside, right? So you need to pick a number somewhere between negative 3 and 3 to test by plugging it into that function. So what number lies between negative 3 and positive 3? 0, 1. It doesn't matter. Pick whatever you want. 0 is usually easiest, but we could pick 1. So I'm going to pick the number 1 to test. So how do I test it? Plug it in. I find h of 1. 1 over what? 1 squared minus 9. So this is 1 over what? Square root of negative 8. Can we do that? No, party foul, right? So if that number doesn't work, guess what? Nothing in between works. So it's not here, which means our intervals are here and here. Now here's my question. Open circle or closed circle on negative 3 and 3? Open, because this tells me it's open. So guys, now I can write my interval notation, can't I? I can also do set builder. Let's do set builder first, because set builder tends to be harder in these cases. X such that what? What is this telling me? X is what? In inequality terms, X is what? Greater than, less than, equal to, greater than or equal to, less than or equal to. That's what we mean when we say inequality. X is what? Right here. That part, right here, this is greater than. That represents greater than. That would be in between. That would be if it were in between. This is from negative 3 down. Thank you. So it's X is what? Negative 3. Oops, I just did greater than. Less than. And, or in this case, since it's separate, or what? What's the other one represent? Where X is an element of the reals. This is actually one that is easier to do in interval notation, isn't it? What is the first interval? From where to where? To negative 3. Union of that with what? Okay, 3 to infinity. All right. Any questions on what you're expected to do here? I've tried to give you lots of examples so you can kind of see what to do. All right. You're going to have to practice this. The hardest part is going to be writing that domain notation. You'll find the exclusions, but then you got to translate that into either set builder or interval notation. And since all of these are the set of real numbers, they all have both, don't they? So you got to be able to do both of them. All right. Let's look at this example. Piecewise functions. It's defined using 2 or more equations, right? Okay. V of x right there is an example of a piecewise equation. Do you know why we study piecewise equations right here? Look what all of these are effectively telling you. You know what all of these are? Haven't we just been talking about domain restrictions? These are domain restrictions, guys. That means that we only use 4t if the domain is between 0 and 15. We only use 60 if the domain is between 15 and 240. We only use negative 6t plus 1500 if t is between 240 and 250. So you have to pay attention to what you're plugging in to figure out which domain it is, because that tells you which function to plug into, doesn't it? So v of 3. Am I going to use the first, second, or third equation? First, because 3 lies somewhere in there, doesn't it? Between 0 and 15. So what am I going to plug into? Yeah, 4 times t, which is 3. So 4 times 3 is 12. So we use the first one. V of 15. I included this one because sometimes people get confused. We have 2 of them that have 15 in the domain, don't we? So is it the first one or the second one? First one. Why first one? Yeah, because the equal to is with the first one and not with the second one, is it? Okay? So what would I get? What would I do to get this one? Yeah, 4 times 15, which is 60. V of 245. Okay, work it out. What'd you get? 30. And since this is a word problem, we should know that that's in miles per hour, right? MPH, MPH, MPH. All right. That is the end of section 1. So now we're going to jump into section 1-2, analyzing the graphs of functions and relations. We're going to continue on with what we know about functions and relations, okay? So, and before I forget, everybody, you need to make sure you look at what we've got. We may not finish 1-2, so you do need to finish all the 1-1 problems. I may pare down the 1-2 if we don't get all the way through the material. All right? So at 3:25, remind me, and then right before the bell rings, I'll tell you which problems we'll cut off there, because I don't want you to miss getting the assignment again. Anytime if.
3:25. Did you guys have the?
Now, you already had the homework sheet from last time you picked it up, but you may have missed what the homework was. It's always on Canvas too. So if I forget to tell you, it's always up there, and then it's always on Canvas. Okay? And if I amend it on Canvas so that you can see it there. But with bus riders, I don't want you to not know what the homework is and be frustrated. All right, so number 1, this is missing some things. It's missing some plus and minus signs here. So let's fix that first, okay? So this little function right here, I want to talk about this function. This function, how do we read function values from a graph? I find that you guys have trouble doing this, and I don't know why. I think it's because it's not something we require you to do a lot. If we have the function 17.7t cubed, okay, minus, there should be a minus sign there, 269t squared plus, I think it's a plus, yep, plus 1,458t minus 910. That is represented by this line right here. I want to know what R of 7 is. How can I use that without plugging in? No calculator involved. Look at the graph. I want to know approximately what R of 7 is. How do I do that on this graph right here? Yeah, I go to 7, and I continue up until I run into the function. That is my input's taking me to the function, and now I can find my output by going where? Yeah, over to the y-axis. Now it's going to be an estimate, isn't it? So what, about 2100? Yeah. I mean, I would take, if I say estimate, I would take a range of values. This is 2500 right here. So it looks like it's maybe 2200, somewhere around that range. Okay? Now, so if we were going to estimate this, right around 2200, so we would say it's approximately 2200, 2100, something like that. All right, so now, how could we figure out exactly what it was? Plug in. Take 7 and plug in. So let's figure out what exactly it is and see if we got close to our estimate. Did you get pretty close? What'd you get? 2186. That is approximately 2200, isn't it? Okay. If you did not get that, then you put something in your calculator wrong. You may have put a parentheses wrong, something like that. Okay? Just double check what you put in. All right, so let's look at the next question. What did it ask you? T is what? Years since what? 1998, right? So how many years after 1998 is, so go back and look on the graph and tell me what it would be 9 years after 1998. Okay? No, you're misreading the graph. Oh yeah, no, that'd be about right. You're right. I'm sorry. We go to here, we go over, and it's approximately what? About 3,400. Okay, 3,350, 3,400. We don't know exactly, do we? Okay, how'd you get that? 2,000. This time we're going over this way, and we're going where? Down. So it's 6 years, but the A here, it says, estimate the total revenue in 2007. Now, this is going to require us, this is more like an ACT type thing where they're not going to give you, estimate the revenue at 6 years after. Well, what are we going to have to figure out first? What's T? What is the T? 2007. 9. So T is 9. 9 years after, right? 7 years plus 2 more. 98 to 2000 and 2000 to 2007. So that's what we're going to have to look on the graph for. So it says estimate. So we're going to say R of 9 is approximately 3,400 million. By the way, 3,400 million is 3.4 billion. A billion is 1,000 million. Do you know how I know that? What is a billion? A million is 6 zeros, isn't it? So, look at that. 1,000 million. Ta-da! That always blows people's mind. They're like, all right, so that should help you with part B where it says 2 billion. If we're looking for 2 billion, but our graph gives it in millions, what are we really looking for? 2,000 million. Now, we've got the revenue, though. So what are we reading from this time? We're looking for what is T. Our answer, that's T. T is 6, so how do we find the actual answer? The year 2004, right? Take it that extra step. This is why I make you do word problems in this class. This is like a word problem, isn't it? where you have to take it. It's not just plug and chug. You're never going to be a better math student if all you ever do is plug and chug, or you ever expect to just plug and chug. Plug a value in, chug a value out. Press on a calculator. You got to think. All right. Finding domain and range from a graph. Woo! Since we're talking about characteristics, and we've been talking about domain, now we're going to look at domain and range. All right. The easiest way I know how to teach this is to teach you how to form a number line on the x. For the domain, we form a number line on the x-axis, and the range, we form a number line on the y-axis. Now I'm going to get up and I'm going to walk over to that screen so you can see and I can refer to it and write at the same time. Here we go. How do we do this? I want you to start, if you're talking domain, that's an x-axis thing, isn't it? So for the domain, we are going to turn this into a number line with shading on it. How do we do that? We go, what is the furthest value to the left on this function? Function is here and here. -4, right? Right here. Come down here. It's at -4, isn't it? Open circle or closed circle? So we're going to come down here, and we're going to put, I'm going to do a different color. I'll do green for domain. Down here, we're going to put an open circle on -4. What is this telling me? The fact that this is solid. It's telling me every one of those x values are used, aren't they? Until we get to the next break, which is where? That's 1? Is that really 1? That's 2, isn't it? It's going by 2s. So 2 right here, right? Okay, and these are both open, so what goes here? Open. So we're going to put an open circle here, and we're going to shade everything this way, aren't we? You'll see why I do this in a minute. What does the fact that this is solid telling me with an arrow on the end tell me about this? Keep going, which means it's still going this way, isn't it? So how do I shade this? Solid, and then off the graph. Do you see why this helps you? Now you've got a number line. You guys know how to do this. You know how to do intervals from this, don't you? So what is the domain? Write the intervals. From where to where? Open circle at what? So we're going from -4 to where? Okay. Union of that with what? 2, 2. For the range, we can do the same thing, but this time we're going to bring it back to the y-axis, aren't we? So I'm going to do it in a different color. I'll pick blue. All of this is at the same level, isn't it? On the y-axis, where is this at? 6. So closed circle. Where is the next place that we see the function happening? Right here, right? So trace this over and we go to where? -2. Open or closed circle? And then what? What is this telling me? Keeps on going, so we shade. Now, the only thing you need to be careful about is how you read it. You read it by turning it this way, sideways. Okay? Sideways, this way. Because we read range from bottom to top, don't we? So we read it this way. So if I'm doing my range is from where to where? From -infinity to where? Union of that with what? It's just one number, isn't it? So what is that number? Blows people's minds that you can do that, but you can. Okay? Any questions about domain and range that way? Does that make sense to you? Try one. Try this one. See if you can figure out on the x-axis where you have values that would be shaded in. Open, closed circle, etc. See if you can do it. Where do they start? Where do they end? If it's solid, then you shade in. starts here, right? Yes?
Mhm.
This is all solid, so this would be shaded. And where does it end? Here,
6.
right? Okay, so it's gonna start at -2 and go all the way to 6.
6.
And that'll be it. And then you can do the other way, going up or down. Is that what you got for your shading for the domain? All right, what is that interval then? Bracket -2, +6 parentheses, right? Okay, so let's do it the other way for range. Where does this start? What's the lowest value you see, open or closed circle? What's the highest value you see, open or closed circle? What's the lowest value? 0. Open or closed circle? Closed, because this one's closed, right? So it starts here. What's the highest value? Open or closed? It touches there, so closed. And what do we do about the shading? Everything between, right? Since it's solid all the way up. So now can you take that and tell me what the range is going to be? Yeah. Bracket 0 for bracket. All right. So try the last one on your own. You want to go from the furthest left to the furthest right. Pay attention to arrows. And then from the furthest down to the furthest up. Everywhere you have a break, like an open circle, which you can clearly see right here is open, you better have a break, right, in your interval. Sorry, guys. I forgot to put mine on silent. Is that what you got for your domain shading? If not, what questions do you have?
Why is it just that?
Well, this is the closed circle right here, so it doesn't go past -8, right? It keeps going, but right here, we've got an open circle, so we had to have an open circle here. Look at this. This is an arrow. That arrow implies up and out, doesn't it? It's not just straight up, it's out this way, so it would just keep on going. Okay?
Oh wait, is the rest of the line shaded on?
Mm-hmm.
Oh,
Everything is shaded from -8 on except for -4.
okay.
So what would my domain be here? How many intervals will I have? First one is from where?
Bracket -8 to -4.
Yep, -8 to -4 parentheses, and then union of that with what? Yep, -4 to infinity. How'd we do? Feeling a little more confident about this? All right, so now range. Have you done the range already? Okay, do the range. From the lowest to the highest, make sure you have places accounted for where there are breaks, right? Holes. Is that what you got shaded? From -8 all the way till we get to 4, and then we have an open circle, and then everything above that. -10, excuse me. Yes, -10. So the range is -10 until we get to, and then union of that, 4 to infinity. Okay. I'm hoping everybody's feeling pretty good about that at this point. Pretty well? All right, good. So let's talk about something that is absolutely an easy thing and a review. Y-intercepts. How do we find the y-intercepts of something? What is the y-intercept of a graph? The y-intercept is where the graph crosses the y-axis. Now, to confirm it algebraically, we need to know, what does that mean? What is this point right here? This is the y-intercept, wouldn't you say? Right here on this one? Would you say that's the y-intercept? What is that point? The point 40 is here. Okay, so be careful. This is the point 0, 4. This tells me something algebraically. Where the line crosses the y-axis, the x value is always going to be what? 0. The x value is 0. So how do we confirm it algebraically? We plug in what? Plug in 0 for what? X. And solve for what? Yeah. Now, a bunch of you are going to see this equation right here. It's this big, long, old equation, right? And you're going to be all, oh my God, I got to get my calculator out. No, you don't. You don't even need to use a calculator for any of these. If you plug in 0 for x, what happens to the term? Okay. So tip and trick for the day. If we are looking for the y-intercept, what can I do to this term, and this term? Mark them out because we're looking for f of 0, aren't we? So what's left? How about that? So it is the point 0, 4 is the intercept, isn't it? And an intercept is a point. That is not an interval, that is the point. So y-intercept. So now, can you do the same thing on the next one? Absolutely we can. What can we mark out there? H of 0. Yep, we're going to mark that out, aren't we? So what are we left with? Which we would leave, unless we were actually graphing it, and then we would figure out what the decimal is, because nobody knows what the square root of 6 is, with the exception of maybe me. It's like 2.4. I know, now she's going to check. Am I right? Yeah, see? To what? I was in the ballpark. I'm pretty good with that. So, anyway, but I'm a math teacher, so I make my living do math. All right, so what would the y-intercept be? How would we write this? The point what?
0.
And does that look like it's about 2.4? So it's about 2.45. Yeah, it's right here. There's 3, so it's about halfway. Yeah, that sounds about right. All right, so the last one, or the last two, here we go. G of 0. Mark out and solve, right? And do the last one also. That whole marking terms out thing is nice, isn't it? So what is the y-intercept? 0.4. Okay. That's your y-intercept. All right, guys, this is where I ended with third block, so I think I'm going to stop here so you all are in the same place. When we get to, it's almost time for the bell anyway, for the bus bell. What do we do? Next time, we're going to finish up the last little bit of 1-2. We don't have a ton left. We do need to talk about x-intercepts and symmetry. And then we're going to do all of 1-3. So we are going to bust it through 1-3. But 1-3 is not that long. It's not that complicated. So 1-2 and 1-3. Now, your homework. Since we're stopping here, you're going to do all of practice 1-1, finish it up. You're going to do 1-2, 1 through 3, and you're going to do the word problems 1 through 3.
Good afternoon.
Front and back,
Austin
1 through 3, and then all of 1-1, front and back. They did the rest of 1-1 last time.
We have Meet the Blackberries tonight. It will be here at the Austin Stadium. It will start at about 5 o'clock. And the varsity team from Austin will probably start about 6.
Okay.
Scrimmage will follow. So it'll be tonight. The cost is $5 here at Austin High School Stadium. Students, just a reminder, at 3:25, the only bus riders and only bus riders only will ride the bus. Again, we had a great 3 days. Hope everybody has a safe weekend, and we'll see everybody here on Monday. Have a good day.
The rest of 1-1, front and back, and 1 through 3 on both sides of 1-2. Sloan, I gotta tell you, be careful. After this week, they're gonna be busting you for that as a dress code violation. I personally don't care, but I gotta follow the rules, all right? So, equal opportunity, and it's not just you. Hey, ladies, if your stomach is showing, if I could tell if you've got a belly button, you're gonna get in trouble for that starting next week. No, yeah, that's perfectly fine. And once you get out of the school, you can just unzip and fly your belly button flag.
Well, now I gotta go work after this.
Sure. It's cool.
Can I go first?